Indeed, machine learning, vectors, and philosophy, oh my. It's kind of like lions, tigers, and bears. I think every talk should begin with who even is this person that's shouting at me and trying to distract my attention from the beautiful world outside. As Tanya said, I've had the opportunity to work at a lot of database companies. I actually started my first consulting firm at 17 in the database space because no one had ever told me that I couldn't, so I just thought that I should. And as I was in university, I discovered the fact that people were willing to pay you, and while university was free, books weren't. And that's quite a bit of money in the US, and so I left my study and moved into the database space. I've been an engineer, I've run sales teams, I've run product teams, I've run marketing teams, but fundamentally, the way that I like to view myself is as a futurist. I am the father of two amazing kids, Gabriella Larit Hannan, who gets her goth from me, and Aoife, who is a star kickboxer, which I guess she gets from her mom. But ultimately, the way that I describe myself is I tell stories about the software that other people build. Generative AI. Every good presentation begins with a bold proclamation. This is not a good presentation. So instead, I'm going to begin with the story of cargo cults. In the first half of the 20th century, the indigenous populations in Melanesia looked on the cargo deliveries that were happening as the cargo planes landed on their island, weighed down with these incredible goods. And even though the islanders didn't really realize where these goods were coming from, they didn't understand the concept of sort of Western manufacturing. They began to imitate these artifacts. So airplanes from straw, and radios from wood, and landing strips from sand, but without the same effect. And this is an example we often use in tech about making the right decisions, the metaphor of the cargo cult. But I think the reality is the truth of the story is something much more sinister. It's not about the indigenous people. It's about the fact that the Japanese forces understood what the indigenous beliefs were and said that they were the ancestors come to bring goods. And then Allied forces later did the same. And so I view this as a cautionary tale for engineers, for marketers, about how we describe the systems that we build to make sure that it is rooted in truth and not in fable. So let's talk about a little bit of machine learning, vectors, and philosophy. Oh my. I want to start with a very brief history of search to set this out. Search engines. Solr, Elasticsearch, Lucene, so many of them, so powerful. For years, I actually had the opportunity to work at Elastic, and I would assert that every problem is a search problem. These engines focused on text capabilities. So fundamentally, text becomes a document, right? The text from each document is then split into its component words. This process is tokenization. And those tokens are put into what's called a bag of words. In its simplest form, this tokenization is like just a sequential process of splitting on white space, right? I think we're all relatively familiar with this idea. And then these terms would be used to build an index in a database, right? Very similar to the index that's found at the back of a book. And it worked. But the count of words could become problematic. And so when searching, the entirety of the index would be accessed and the matching documents were identified, and a calculation would be performed for each document, and it would compare the search text to the document terms. And this relevancy calculation, relevance is an important concept. Is the word "and" relevant? Not likely. It's not going to provide you any additional context into what it is that you're searching for. But this became important in wider corpuses of text, and it became known as term frequency, inverse document frequency. This is the 1970s. BM25 came along and improved on that. And that is where we have been in search for fundamentally the last 20 years. It's incredibly powerful. It's incredibly useful when you need it. But there's an emergent property, and it's this question of meaning. The challenge with the traditional search approach is it fails to capture meaning or context of the words themselves. The example that people often use is the cat watched the bird through the window with interest is, in search, identical to the bird watched the cat through the window with interest. Two fundamentally different concepts, but they're treated as equal because context isn't really understood. Here we have the sort of emergence of what's called vector search. And I want to spend a little bit of time talking about how vectors work and providing you a little bit of background on vector and embedding, and then I'll show off some of the things that we've played with at ClickHouse. So what is a vector? In mathematics and physics, a vector is very simple, right? I've got an object and it has magnitude and it has direction, right? Fairly straightforward. A 10-dimensional vector, as you can see up on the screen, would be 10 notes of object and direction. Very difficult to sort of comprehend in, we live in a three-dimensional world and sometimes can sort of notionally parse the concept of time, although given the level of jet lag I have right now, I'm not sure that's actually true. But this notion of a vector is really just an array, and it's an array of points, right? Then there's the notion of an embedding. In machine learning, vectors it's the same data structure, but an embedding is the set of numerical values that try to define the context of whatever it is that you're embedding. So in this example, I say moonlight, right? And we have this array of points, and these points represent things like color temperature, or directionality, or mood, or brightness, or warmth. And this becomes the way that you can embed context in a vector. The thing that OpenAPI did that really sort of changed the way that we think about this, and this was in 2021, is they introduced CLIP. And CLIP is a sort of modal model that allows you to encode embeddings to create vectors on images, on labels of images, and to be able to store those so that you're able to interact with that vector. This was really sort of fundamentally where the LLM space, where other things began to kick off, was at the emergence of CLIP. And so then really the question becomes the importance of distance. So I've given you sort of a quick overview of it's 25 minutes, I can't get into all the maths, of what a vector is and what an embedding is, but what does that actually mean? And what it means is this. To understand how these can be compared to one another, you can just picture a vector as a single point in high-dimensional space. So again, I have 3 dimensions because human brains are limited. But these 3 dimensions are the embedding for moonlight, the embedding for flashlight, and the embedding for animal. And you can see that moonlight and flashlight are physically, geometrically closer to one another, which would mean that they are similar in some sense. Now, this is happening in typically thousands of dimensions rather than 3. However, the great part about Euclidean math and the simple Euclidean distance is it works in all of those dimensions. And so you're able to be like, I actually want to see what is similar. And so the concept then becomes, I'm not searching text, I'm searching vectors. And a simple example of that would be this. So here's a very, very standard embedded vector, and I want to do a full scan against my database for the most relevant document or set of documents, ordering by distance. So here's all my stored vectors. I'm going to order by Euclidean distance. I'm then going to sort that by ascending, and then I'm going to return the document ID. This is fantastic. Flashlight, moonlight. This is expensive. And this is why GPUs shot through the roof for a long time. Not only creating the embeddings, but how do I spend time actually doing the maths around determining what the similarity in distance is in this vector space. Fundamentally, this is what machine learning pipelines are doing behind the scenes. Pick a ChatGPT, pick a Dwayne, pick another LLM model. This is what's really happening. But it's expensive. And so instead, you have to think of other ways of doing approximate representations of that search rather than specific representations of that search. Does anyone have a clue of what this image might be? Cool, because I didn't either until the CTO created it and was like, this is what it is, and my brain broke. So I'm going to have to be a little hand-wavy here. I have these vectors, right? And these vectors are, again, dimensions in space. So think of it as these 2 points. If I have these 2 points, and I draw a hyperplane between them, and I give one side of the hyperplane a negative value, and the other side of the hyperplane a positive value, and I continue to do this for all of the points in my data set across the thousands of dimensions, I'm building an index, and the index is known as the approximate nearest neighbor index, or ANNOY, which may be one of my favorite terms in tech. How are you going to solve that problem? Annoy, right? Great, that's what I do for a living. I annoy. So this is actually a visual representation. What you can see is my data set probably lives somewhere in the middle, in that upper sort of left quadrant where it's so dense, and things become more and more sparse over time. This is incredibly beneficial in applications where the data set's large. In fact, one of the ones we'll look at in a second is enormous, and where the search has to be performed quickly. There are other examples of this, HNSW, but Annoy is the one that I think has become perhaps most common. So I work for ClickHouse. So I'll give you an example of what vector search sort of looks like in ClickHouse, the way that some people are using it, and then I'm just going to show you some really interesting examples of it. So vectors are just an array, as I said. And ClickHouse is great. We support float 32. That's 1.5 to 2 times compression. Compressing numbers is actually a very difficult thing to do. Matching is just a distant function, as I mentioned, mainly Euclidean or cosine. But there's support for full SQL. And this actually becomes very interesting here in a second. Annoy is supported, UDFs are supported. We see people using this for the things you might imagine, recommendations, questions and answers. Fraud, I think, is a really interesting one. If I know the behavior encoded as a vector of someone who has a positive payment workflow, and then I see the behavior as a vector of something that's completely dissimilar, perhaps that's fraudulent. So it really opens up these fantastic use cases. Here's an example. So we actually open source this. This is the Lion data set, which is a prepared set of embeddings. It's available publicly for download. In fact, if you go to our docs, we show you how to import it into a cluster because we remodified everything as Parquet files because it's easier to deal with. It's about 5 billion images. The reason we use this data set, Lion, is because at the time, at least, it was the largest one that we knew of. And it consists of embeddings, 768 dimensions, across several billion public images on the internet, including their captions. It's generated through simply a public crawl of the internet. And it was created with the explicit purpose of testing vector search. So when we interact with this data set, I've imported it into ClickHouse, yay, everything's happy. I'm basically doing select. I want to get a URL, I want to get a caption, based on the distance from an image embedding, where the similarity is close, I want to order it, as I mentioned, I want to limit it, and I want to format it. This vector is actually a picture of a friend of mine and colleague, Dale McDermott, his Rhodesian Ridgeback. And so we dropped it into ClickHouse and got back a stack of public images of Rhodesian ridgebacks. And we thought, wow, that's super cool, but I had to know how to create the embedding. So in that same repository, if you want to play with this, there's actually a set of Python scripts that allow you to interact with the data via a simple UI. This is a particularly cool one. This uses sort of the SQL aggregations that I talked about. So it's the concept of Berlin minus Germany, plus the concept of the United Kingdom and a bridge. So notionally, if you think about it, I've got Berlin and I'm removing Germany. So maybe I'm left with the concept of a capital. And I've got the UK and a bridge, so maybe a capital and a bridge should show something like London Bridge, and in fact, that's the first thing that returns, is Claude Monet's painting of the London Bridge. It also shows a bridge in Venice, which, vector search is a thing. Or you can do really interesting things like, what is the intersection of cubism and surrealism? So this is cubism plus surrealism divided by 2. But what does it mean? Here's where we talk about philosophy. Ludwig Wittgenstein said, meaning is use. Maurice Merleau-Ponty on contextual understanding said, we don't perceive objects as such, but rather as nexuses of relations, vectors, in constant transformation. And perhaps one of the most well-known, Jacques Derrida said, there is nothing outside of context. And so as I was working on this presentation, I started thinking about what are the philosophical tensions in vector search that I feel? Statistical similarity versus essential meaning, whether meaning is inherent or emergent in vector representations, and my brain broke and I was jet lagged, and so instead of diving into them in detail, I asked Claude to write me a joke about Jacques Derrida. And Claude said, Jacques Derrida walks into a cafe and orders a coffee. The barista asks, would you like that with cream and sugar? And Derrida replies, if I say yes, do I mean the presence of cream or the absence of black coffee? If I say no, am I affirming the purity of coffee or negating the addition of cream? The binary opposition of yes and no fails to capture the differences inherent in my coffee preference. The barista stared blankly for a moment and said, so just black then? Derrida sighed and said, there is nothing outside of the coffee context. The barista simply wrote pretentious on his cup and called out the next customer's name. So I said to Claude, this is interesting. Where did you get it from? This was a new generation. It is not an existing bit of humor. And this is where I would have stopped the talk if the world hadn't fundamentally changed in the last 2 months. And when Tanya and I first talked about this, we were going to lean into the philosophy, but instead, I want to touch quickly on AI agentification, because it's not the verbing that weirds the language, it's the renounification. Some properties that make real-time databases particularly useful in the space of AI agents are their ability to scale based on workload. Working with near real-time data, allowing it to process and deliver insight almost immediately as new data arrives is crucial for the agent to be useful. And so at ClickHouse, we started talking about the concept of AI agents and how do we think about them, and we see people using them and deploying them. And our colleague Riyadh, who looks after everything AI related for us, was like, I'm gonna build a user persona for Chatty McChatface. And Chatty McChatface is potentially an uncapped number of AI agents running a large number of queries on behalf of the user to perform investigations, to reiterate over result sets to try to derive insight. And so we built a ClickHouse MCP server. This is also open source. Feel free to play with it. In November 2024, Anthropic announced the Model Context Protocol. If you're interested, dive into it a bit. We recently released this as an official MCP server that bridges between AI models and in our case, ClickHouse, right? But there's these for a wide variety of databases, of text-based tools. They're incredibly interesting. And so last night, I asked it to build a bar chart showing the rise of contributors over time to the ClickHouse repository. This is just an agent, it's actually a public one, that connects to all of our sample data, and we ingest all of the GitHub event data set. And it built this chart for me. I had to ask it twice because it forgot the first time. This is using LibreChat deployed to an EC2 instance. There's also a ClickHouse MCP server there. The MCP server connects to the demo database, and LibreChat is using the Amazon Bedrock API to actually call out to the Anthropic model. And it gave me this lovely chart of repository contributor growth over time. What it really did was it ran some SQL. And the first thing it did is it said, hey, what databases are available? Because we didn't provide it business context. And it says, it looks like Git and GitHub might have data. Let me list the table. Let me see or list the rows. Let me see what's available in the columns. And then it wrote a relatively simple select. Select 2 year as time, quarter from the Git ClickHouse commits, and then order it. But then it also did this. It created something I didn't ask for, which was new contributors per year to the ClickHouse repository, and then it put context beneath it, some key insights. The ClickHouse repository has seen exponential growth in contributions since becoming open source in 2016. From just 39 contributors in 2015, it grew to over 1,700 by the end of 2023. That is true. But I know the why. I have the context to provide to this insight. There is meaning, but it's us that impart understanding. So I'm going to end with an assertion. What does this actually mean? I encourage you to explore these tools. LLMs, vector search, annoy indices, AI agents, explore them. And as you explore, question the capability, explore it mindfully, provide the context and meaning of your own understanding into what you are doing, and then build systems that acknowledge the power and acknowledge the limitation. Start with a solid foundation. I like ClickHouse, there's a lot of great things, but build from there. These systems are not magic, and they're not sentient. They're just really, really freaking good at pattern matching. Better than I will ever be. But I am really, really freaking good at providing context to the patterns that were matched, as are you. You have that superpower that the machine does not. Don't build a cargo cult, build product, and build it mindfully. And I guarantee that everything will change, which is why I end with the thing my father always used to say to me, and the reason that I played golf and was a dancer and studied philosophy and thought theoretical mathematics was interesting and still am a musician, is blessed are the flexible, for they shall bend but not break. That was 24 minutes on the nose. Thank you so much. Feel free to give it a scan. Tell me where I was good. Tell me where I was not good. We have a standout in the lobby if you want to chat more about it. And the next talk that are coming up in this room is Enhancing the Developer Experience. Next door is May the Cloud Be With You, I believe. And yeah, appreciate the time so much. Shout out to all of the Latency crew who have made this event happen, and I appreciate you listening to me shout at you for so long. Cheers.
Woo! Thank you.